Hello everyone, and welcome to Biomechanics Sports Center. Today, we're going to talk about lacrosse, more specifically, the difference between a long and short pole and how they affect the speed that you can get the ball to travel with. In lacrosse, there are two lengths of sticks that can be used. The shorter offensive stick is 1 meter long, and the longer defensive stick is 1.5 meters long. Today, we're going to compare the two and determine how fast the ball can travel from the stick with a given angular velocity. Do you think the ball will travel faster using a short stick or a long stick?
What is angular velocity? Angular velocity is a measure of how quickly an object is rotating around a fixed point. More specifically, it is how many radians the object spins around in a circle in a given period of time. When we use the angular velocity, we can figure out how fast a point on an object is moving tangentially to its path around a fixed point. That velocity can be calculated by adding the velocity of the first point to the cross product between the angular velocity of an object and the distance between the 2 points. A cross product is a type of vector multiplication. If you're unfamiliar with this concept, we recommend watching the YouTube video linked below. In the examples we're doing today, the velocity of the first point is 0 because the point is fixed. So our equation will reduce to the tangential velocity is equal to the angular acceleration times the length of the stick.
First, let's find out how fast the ball will go with the short stick. In our examples, we are going to assume that angular velocity is constant at 15 radians per second. To solve for how fast the ball will leave the stick, we take the angular velocity that we're causing the stick to move with and multiply it by the length of the stick. Here, this is 1 meter. So 15 times 1 is 15 meters per second, which is what the ball will leave the head of the stick at. Let's see this in real life.
Now, let's find out how fast the ball will go with a long stick. The equation we are using stays the same. The point representing the hand of the lacrosse player is still fixed, and the angular velocity is still 15 radians per second. The only thing that is changing is that the length of the stick is now 1.5 meters long instead of 1 meter long. When we plug in the values to our equation, we end up getting a velocity of 22.5 meters per second. So we can conclude that when the ball leaves the head of the long stick, it is traveling with a velocity of 22.5 meters per second.
As we have observed from the two examples and calculations, we can tell that if the same angular velocity can be exerted on both sticks, the ball will travel 7.5 meters per second faster off of the longer defensive stick. This is biomechanics and angular velocity at work, and pretty interesting stuff. Just by changing the length of your lacrosse stick, you can greatly change the speed that the ball travels. That's all for this time. Join us next time on Biomechanics Sports Center.